So in this video, we are going to use substitution of x equals to cos x cos 2x to prove that the integral from -1 to 1 of the root of 1 minus x 1 plus x dx is equals to pi. So if you are new to this channel, this is Bams's Academy. So don't forget to like, share, and subscribe to this channel. So if you think you know how to do it, you can pause the video and go ahead. Let's see if we get the same thing at the end of the day. So what I want to do is to first of all substitute what I've been asked to. So I've been asked to substitute x to be cos of 2 theta, right? Which means that my boundaries that were initially x. So when my boundary x is equal to 1, then I want to find what theta would be. So I would say that 1 is equals to cos of 2 theta. So 2 theta here is equals to the arc cos of 1, all right, which means that 2 theta here is equals to 0, then theta will be equals to 0. So we've gotten the first boundary here, right? So then for when x is equal to a -1, so I'm going to go ahead to do the same thing by saying the -1 is equal to cos of 2 theta. Then I'll just say 2 theta equals to the arc cos of -1 here. So this one here would be 2 theta equals to 180, because cos 180 is -1. So in terms of pi, because we are working towards pi, that would be pi. Then the theta for our boundary will be pi over 2. Okay, so that's the boundary that we want to work with. And also we need to also convert this dx. So we've been able to convert the boundaries here. That's what we've gotten. So let's go ahead to convert the dx. So for the dx, we note that x is equals to cos of 2 theta, which means that dx will be -2 sine 2 theta, the theta. Okay, so now, which means that my question can be written properly like this: pi over 2 to 0, then the root of 1 minus cos 2 theta over 1 plus cos 2 theta. Do you get? Then times my dx is now -2 sine 2 theta, then d theta. So this is exactly what we want to show, that it's equal to what we are trying to get. So I'll start from there so we can get whatever we want to get. So this is what we want to solve now. Now, considering this question, what we'll do next is that now we need to recall something very, very profound. Recall from half angle. Now, if you recall from half angle, you remember that the sine of theta is equal to the root of 1 minus cos 2 theta over 2. And you also know that the cos of theta is equal to the root of 1 plus cos 2 theta over 2. Which means that if I should decide to take the tan of theta, which is, in other words, sine over cos, right, I will be having something like the root of 1 minus cos 2 theta, which is representing my sine, then over 1 plus cos 2 theta over 2, which is representing my cos here. Then 2 cancels 2. Then I can say that it will be 1 minus cos 2 theta over 1 plus cos 2 theta. So in essence, this whole expression here is the same thing as tan theta. Do you understand? So we will fix that into the question, then we will solve, knowing fully well that this is now the integral from pi over 2 to 0, then tan theta, which is the same thing as writing sine sine theta over cos theta. We've proven that earlier, times minus 2. Now sine 2 theta from our trick is the same thing as writing 2 cos theta sine theta, right? So I'll fix that into the question. So times 2 cos theta times the sine of theta, still having my d theta there. So it shows that this cancel out this. I'm left with something very easy. So I still have 2 times 2, which is 4, and the minus. So I would have in essence minus 4, the integral of pi over 2 to 0, then sine square theta. Then from the half angle I just stated, remember that sine theta is equals to the root of 1 minus cos 2 theta, right, over 2, which states that sine square theta will now be what? 1 over 2 minus cos 2 theta over 2. Okay, so knowing this fully well, I can now apply it into what I want to solve. So now I would have in essence minus 4 here to the integral of pi over 2 to 0. Then I would have 1 over 2 minus 1 over 2 then cos 2 theta d theta. So it's left for us to integrate this particular expression. So now if I'm to integrate this, separating the integrals, I would have this will be theta over 2, then minus 1 over 2 times 1 over 2 sine 2 theta. Then it's ranging from pi over 2 to 0. Alright, so if I should fix in the upper bound, that is minus 4 into 0 over 2 minus 1 over 4 here, then sine 0, then fixing the lower bound, which is pi over 2, then over 2 minus 1 over 4 sine 2 pi over 2. You see that now? What do we have? Remember, we see that we have would have minus 4. Now it is obvious that the whole of this bracket, this will be 0, sine 0 is 0, so this is also 0. So I'm left with a minus here, minus pi over 2 will be pi over 4, okay, minus, then if 2 cancels 2, sine 180 is 0, so the whole of this here is going to be 0. I'll fix that in, that's 0, then I'm left with minus 4 into minus pi over 4. And if I should say 4 cancel 4, plus minus times minus is plus, then in that case would have a pi, and that's exactly what we are trying to get. As simple as that. So that's how to solve it. Let me know what you feel about this in the comment section, and I'll see you in the next video. But before you go, don't forget to like, share, and subscribe to this channel. I'll see you in the next one. Bye for now.